So in this video we're going to be working through a differential equations exam question involving partial fractions. This is on the A-level specification. Part A says express 8x minus 18 divided by 3x minus 8 times x minus 2 in partial fractions. So the first thing I need to do is set up my form that I'm going to split the fraction up into. So we're going to write down the fraction that we're given in the question. And I'm going to say that that's equivalent to a over the first part of the denominator plus b over the second part of the denominator. And that is my form, or my setup, that I'm going to use to split this fraction into partial fractions. So the first thing I'm going to do now is multiply everything by this denominator of our big fraction. So we're going to get 8x minus 18 is equal to a times, when we multiply this, the 3x minus 8 will cancel with this 3x minus 8, leaving us x minus 2. And the same thing for the b. The x minus 2 this time will cancel with the x minus 2, leaving us 3x minus 8. Okay? And now what I'm going to do is I'm going to find my values for a and b by substituting in the critical values that make either of the brackets equal to 0. So the first critical value I'm going to substitute is when x equals what will make this bracket 0, it's x equals 2. So 2 times 8 minus 18 is 16 minus 18, which is minus 2. That's then equal to, this bracket will cancel because we'll get 0 times a, which is just 0. And 3 times 2 is 6, minus 8 is minus 2, and that's then multiplied by b. So from that we can say therefore b equals 1, and that's our first value for b. Now we need to look and say, well, what's our second value that will make the other bracket equal to 0? And that's x equals 8 over 3. So putting that into the left-hand side, we're going to get 10 over 3. And putting that into the right-hand side, it will cancel this bracket here, because then that will make it 0, so 0 times b is just 0. And 8 over 3 minus 2 is 2 over 3, and then we're multiplying that by a. So therefore what we're going to do now is work out our value for b. We can multiply everything by 3, and then divide by 2, we get a equals 5. And that's our value for a. So we haven't finished just yet, because now what we want to do is put that back into this form here. So we're going to say, therefore, I'm just going to move that over a little bit, draw a line. Therefore, 8x minus 18 divided by 3x minus 8 times x minus 2 is identical to, the 5 went over the 3x minus 8, so we're going to get 5 over 3x minus 8, and then the b went over the x minus 2, so plus 1 over x minus 2. And that is our final answer. Part B then says, given that x is greater than or equal to 3, find the general solution to the differential equation x minus 2 times 3x minus 8 dy dx is equal to 8x minus 18 all times by y. So the first thing we're going to do when we're asked to find a general solution to a differential equation is get all of our y's onto one side and all of our x's onto the other. And when we do that, we take our y's over to the side with dy dx on, and our x's over to the other. So the first thing I'm going to do is I'm going to divide both sides by x minus 2 times 3x minus 8. So that will give me dy on dx is equal to 8x minus 18 divided by x minus 2, 3x minus 8, and we're still multiplying that by y. Then what I'm going to do is take this y over to this side, so we've got the y with dy. Okay, so the y is going to come over to this side because we want it with our dy on dx. So that means we're going to have to divide both sides by y. We're going to get 1 over y dy dx is equal to 8x minus 18 divided by x minus 2, 3x minus 8. And now what I'm going to do is I'm going to multiply both sides by dx, because we don't want any x values on this side, we want them all y's, and on here we want all the x's. So multiplying by dx on both sides, we get 1 over y dy is equal to 8x minus 18 divided by x minus 2, 3x minus 8 dx. So just recapping on what we did there, we wanted all of our y's on one side, all of our x's on the other, and the y's go on the side with dy dx. So the first thing we did for this step was we divided by x minus 2, 3x minus 8, and for this step we then divided both sides by y, and for this step we times both sides by dx. Now what I'm going to do is I'm going to integrate both of these parts. So I'm going to integrate the part with the y in, and I'm going to integrate the part with the x in. Now, part A links with part B because we're unable to integrate this. However, we've just split that up into partial fractions. So what we can say is integrating 1 over y with respect to y is equal to, and then we're going to change this fraction here into its partial fractions equivalent, which we just worked out was 5 over 3x minus 8 plus 1 over x minus 2. And make sure you get the right numbers over the right bracket, and we're going to integrate that with respect to x. So now all we're going to do is just integrate as normal. So 1 over y integrates to the natural log of the modulus of y. And then integrating the right hand side, 5 over 3x minus 8. So if we have a look at the 3x minus 8, when we differentiate that, we actually get a multiple of the numerator. So we know that we're going to get a natural log. So we know we're going to get the natural log of the modulus of our denominator, which is 3x minus 8. But we're also going to then have to times by 5, but also divide by 3, which is what we get when we differentiate the bracket. And doing the same thing for here, we're going to get 1 lots of the natural log of x minus 2 divided by 1, which is just the natural log of the modulus of x minus 2. And we've integrated, so don't forget plus c. And it doesn't ask to give that in a form, so that's just a general solution. So that is our final answer. Part C says, hence find the particular solution to this differential equation that satisfies y equals 8 at x equals 3, giving your answer in the form y equals f of x. So I'm going to write down the answer that we got for part B, which was the natural log of the modulus of y plus 5 over 3 natural log of the modulus 3x minus 8 plus the natural log of the modulus of x minus 2 plus c. And we want a particular solution, so we're going to have to work out what our plus c value is using y equals 8 and x equals 3. So when y equals 8, we know that x equals 3. So let's put that into this equation here. So we're going to get the natural log of 8. We can remove our modulus now because 8's always going to be positive. 5 over 3, the natural log of 3 times 3 is 9, minus 8 is 1. And again, removing the modulus because 1's always going to be positive. Plus the natural log of 3 minus 2, which is 1. And again, we can remove the modulus there. And then plus c. Right, when we get the natural log of 1, we know that that's 0. So this is going to cancel. And this is going to cancel. So therefore, we can say c is equal to the natural log of 8. So now let's go and put that back into the original thing that we started this question with, which was our answer for part B. So putting that in, we're going to get the natural log of the modulus of y plus 5 over 3 natural log of the modulus 3x minus 8 plus the natural log of x minus 2, and again that's modulus, plus the natural log of 8. Now it wants it in the form y equals f of x. So what I'm going to do before I get rid of our natural logs is simplify as far as I can. So the first thing I'm going to do is I'm going to say we can bring this 5 over 3 up to the top there. So the natural log of the modulus of y will equal the natural log of the modulus of 3x minus 8 to the 5 over 3, using a log rule there. And then I'm going to be multiplying these logs together, because an addition of a log, we then multiply them together. So we're going to get the natural log of the modulus of 8 times x minus 2. And now we can simplify that even further. Because we're adding two natural logs together, we can bring them into one natural log and multiply them. So the natural log of the modulus of y is equal to the natural log of the modulus 3x minus 8 to the 5 over 3 multiplied by 8 times x minus 2, and close our modulus. And now it's easier for us to remove our natural logs. And the way we do that is actually raising both of these left-hand side and right-hand side of the equation to the power e. So e to the power of all of that will get rid of our natural logs. So we're going to get y equals, and then I'm going to simplify this. I'm going to bring the 8 times x minus 2 to the front and multiply that by 3x minus 8 to the 5 over 3, and then that is our final answer.